Hello everyone, this is tutorial 12 of Math 2000. Today I have 3 questions to go over, so let's jump right in. Question 1, use this transformation to calculate the integral with the region bounded by these curves. And as you could see, I've already graphed it for you. Okay, so the first thing is to figure out what the Jacobian is. So we have x is equal to u over v, and y is equal to v. So then, the Jacobian is x with u, x with v, y with u, y with v, and then take the determinant. So x partial with u is 1 over v. That's minus 1 over v squared, 0 and 1. And then you take the determinant, that's 1 over v. That's your Jacobian. Then we want to figure out how does the bounds look like in terms of u's and v's. So bounds using u's and v's. So the first thing is we notice that we had y equals to 3 over x and y equals to 1 over x. These two are solved similarly. So that's 3 is equal to xy, x was equal to u over v, y was equal to v, so that's just u. And very much in the same manner, this is just going to be 1 equals to u. So we know that, so therefore we know that the u values go from 1 to v, and 1 to 3. So those are the bounds for u. Now you want the bounds for v. So before we were told y is equal to x and y is equal to 3x. So then y is equal to x tells me that v is equal to u over v, and then that tells me that square root u is equal to v. Yes. And then this one tells me that v is equal to 3 u over v. And then what does that tell me? In a similar manner, it tells me this. So in this case, because u moves from 1 to 3 freely, then for the v values we have this. Okay. So before, our x's and y's look like that red region there, and now our u's and v's look like this. So if I were to graph that out quickly, it looks a little bit like this. So let's say that's u, and that's v. So it looks a little bit like this. And then let's say this is 1 and this is 3. So in terms of u's and v's, our region is now like that. Okay. Now we're ready to take the integral. So the double integral of xy dA over the region R. So x times y, what was that? That was just, what was x times y? X times y was just u. X times y was just u, but the Jacobian was 1 over v. And I'm going to do it in terms of dv du. And then now it's 1, 3, root u square root 3. So recall, xy was just u, and the Jacobian is 1 over v. So at this point, you just integrate as per usual. So integral with respect to v. So that becomes this. Simplify. Because it's a ln, you could write it like this instead. Because it's a ln, and you simplify that. So that's u ln root 3. And then this, I believe, is just, it's 1/2 u squared, so 9 minus 1. And that could be simplified. So 2 ln 3. And that's it for question 1. So the trick is use the Jacobian, make this region into a much nicer region down here, and then integrate as per usual. And that's all for question 1.